So I was continuously getting stuck on these kind of questions. So sine theta, sine 3 theta, sine 5 theta, so on till sine of something theta. So that something must always be an odd number, and you have some special condition that theta must be pi upon 2n. So n is an even integer, even natural number, you can see. So we want to find what this product s is. Uh, so here's the setup. I will say that z is e power I theta, and then z power n will be I, because yeah, so e power I pi upon 2n, so raised both to the nth power, so e power I pi by 2, which is I. So from that, z power 2n equals to -1, z power 4n equals to 1, and we know that sine alpha can be written like this. And now let's get to it. So sine 3 theta, sine 5 theta, so on. So we're going to write it like this using this formula. So sine 3 theta, it will be like e power I 3 theta minus e power minus I 3 theta, and then it's just basically e power I theta to the power of 3. So that's going to be z cube minus e power minus I theta to the power of 3, which is z power minus 1 to the power of 3. So 1 upon z cube. So you can write it like this. From there you can cross multiply, so it's going to be z square minus 1, z power 6 minus 1, z power 10 minus 1, so on, upon. So how many terms are there? There are n by 2 terms. Yeah, so 2 times of n by 2 minus 1, so there's going to be n by 2 terms over there, because it's the n by 2 odd number. All right, so you're going to have n by 2 of these 2i's, so 2i to the power of n by 2, and then the denominators, they are going to club up to give z power 1 plus 3 plus 5 and so on till n minus 1. So this is well known that the sum of first x odd numbers, that will be x squared. So over here there are first n by 2 odd numbers, so it's going to be n by 2 squared, so it's for z power n by 2 squared. All right, so now this can be factorized, so z minus 1 into z plus 1, z cube minus 1, z cube plus 1, and so on. So I have taken this minus stuff in one bracket and all the positive stuff in one bracket, and I'm going to write this z as negative z upon z power 2n, because z power 2n is -1, so negative negative positive, so it's the same thing, just written like this. So on calculating this, you will get this as the thing. So there should also be the denominators, which we have taken over here. So z power n plus 1 plus n plus 3 all the way till 2n minus 1, right? Yeah, so 2n minus 1, that's the first one, then you got 2n minus 3 and so on, and the last one will be n minus 1 upon z power n minus 1 upon z power 2n, so it's going to be 1 upon z power n plus 1. So cross multiplying that thing, you should get this thing, z power n plus 1, and then so on, right? So this looks a little more complete and stuff. Okay, so this is written like this: z minus 1 into z cube minus 1, so on till z power 2 minus 1. The denominators become like this. So there are still n by 2 terms. N is getting repeated, so n times n by 2. There's this n by 2 squared, which was from earlier, and then you got 1 plus 3 all the way till n minus 1, so that's once again n by 2 squared. So this thing is n squared by 4 plus n squared by 4, which is n squared by 2, and this is once again n squared by 2, so it's going to be n squared. So z power n to the power of n, basically that's n into n, so we can write it like z power n to the power of n, and z power n, we know it's just iota, so it's going to be I to the power of n, so n plus n by 2 is 3n by 2, that's why this is over here. All right, and this product n to power n by 2. So this is our s. Basically I should be writing this as p, but whatever. Yeah, so this is the first equation. Now we're going to modify this a little. So z power 4 and that will be 1, right? So we can multiply by z power 4n on numerator and denominator of this z. So the numerator one, we will just call that 1, and the denominator one, we will let that be z power 4n. So z power 4n upon z, so that will be z power 4n minus 1, so that's why this is in the denominator. All right, so we have written it like this. So the last one, it's going to be 2n plus 1, which I'm going to write as the first one, but you get it. So cross multiplying, once again we get this thing. Yeah, this looks correct. All right, so z power 2n plus 1 minus 1 and so on. So like it should be minus 1 over here as well. but you get it, right? So yeah, and all the denominators as well. So 2n plus 1, 2n plus 3, all the way till 4n minus 1. Now 4n minus 1 is more like 2n plus 2n minus 1. So 1, 3, so 1 till 2n minus 1. There are n of these, right? Because there are basically n of these numbers multiplied. All right. So yeah, this should be 1. Why is this iota? All right. Where was I? So 2 power n by 2, iota power 3n by 2. And what's this thing going to be? So you got n of 2n's, so 2n squared, and then 1 plus 3 all the way till 2n minus 1. So this should be n squared. Cool. So it's going to be z power n to the power of 3n. So that's iota to the power of 3n. So iota power 3n by 2 plus 3n. So that's also this value of s. So multiplying 1 and 2, so multiplying this equation and this earlier equation that we got. So why are we doing that? Because 2n minus 1 and then plus 2 is going to give us 2n plus 2, so n plus 1, sorry, and so on. So that means that we can continue this. Basically, we are extending this thing till 4n minus 1. So multiplying this, we get z as s square. Okay, why? Because s times s like s square. All right, cool. So this should be 1 minus z cube all the way till 1 minus z power 4n minus 1 upon 2 power n by 2, 2 power n by 2, that's 2 power n, and this thing 3n by 2, 3n by 2, 3n plus 3n is 6n. So 6n is a multiple of 4 because n was even, so 6n is definitely a multiple of 4, which means iota power 4 and that to power some integer. Okay, so that means it's just going to be 1. So we can just ignore this thing, right? So s squared is this thing. Now here's the trick part in this thing. Consider this equation: x power 2n plus 1 equal to 0. Basically x power 2n equal to minus 1. This is satisfied by all of these numbers, z cube and so on, right? Why? Because these are all just odd powers of z, and we know that z power 2n, that's going to be negative 1. So z power odd to the power of 2n, that's the same thing as z power 2n to the power of odd. So that's going to be negative 1 to some odd power, which is negative 1, which means yes, all of these do satisfy it. And in fact, these are all of the solutions for this equation. Why? Because there are exactly 2n of these numbers, right? So here I've written everything. So x minus z cube, all these are just factors of this equation, this polynomial. All right. Since the equation has at most 2n complex roots, and because its degree is 2n, and we have 2n different numbers, so yeah, it's different. Because if you write it in the polar form, you will see that the arguments, they are positive and they are between 0 and 2n, 0 and 2 pi, which means they all represent different points on the unit circle, right? So that means that all of those are different numbers. Yeah, so we have 2n complex roots and different complex roots, so they are unique. So that means that they are all the roots that you could actually get. So we can just kind of factorize that and not worry about any other question that might come in, because there won't be anything, right? There's not going to be any other question. There's just no root other than these. So that means that we can write x power 2n plus 1 as this thing, and now everything starts to fall in. So just put x as 1. That means 2 equals to this product, whatever this is. So our s squared thing, that's going to be 2 upon 2 power n. So this 2 power n is from earlier, this one, and then this complete thing, that's going to be 2. I don't want that. Okay, so s is so 2 power 1 minus n upon 2, easy as that. So that means sin theta, sin 3 theta, sin 5 theta, all the way to sin n minus 1 theta. This is going to be 2 power 1 minus n upon 2, where theta is pi upon 2n, and n by 2 is a natural number, which means n is an even number, basically. All right, so that's it. I couldn't find this formula or whatever this is anywhere on net, so I had to write it like this. Yeah, I don't know why they don't teach it, or maybe why it's not popular, but I couldn't find it anywhere. So yeah, hope this helps. See you in next time.